This is our E. coli culture. What we're trying to determine is what is the colony forming units per milliliter of this solution. So to do so, we're going to dilute it by a factor of 10 over and over and over until we have a very small amount. The way we do that is we're going to do 6 here. Each one of these test tubes has 9 milliliters of water in it, and we're going to take 1 milliliter of our solution here and add it to our test tube. So then it becomes 1/10 of that test tube. So it's 10% of that test tube, or a 1-to-10 ratio of that test tube. And so another way to write 1/10 or 10% or 1-to-10 or 0.1 is 10 to the negative 1. And then we're going to take 1 milliliter from this test tube and add it into this one. And so now we have 1/10 of 1/10, which is 1/100th. Another way to write that is 1%, or 1 to 100, or 0.01, and then 10 to the negative 2, because it's a factor of 10. We're going to repeat that process, and we're going to get 10 to the negative 3, 10 to the negative 4, 10 to the negative 5, and 10 to the negative 6. So going back over here, we have 1,000th, we have 1/10,000th, we have 100,000th, and then over here we have 1/1,000,000th of the original culture. So what we're going to do, we have 1/1,000,000th, or 10 to the negative 6. We're going to put 1 milliliter of that, because we're calculating CFU per 1 milliliter. We're going to take 1 milliliter of this, and we're going to put that on a TSA plate, and then we're going to let it grow. And then we're going to count the amount of colonies that are on that plate. So we incubated this for a while, and then we counted it up, and we got, keep it simple, we're going to say there's 80. Back over here, we know we have 80 colonies that were counted in the 10 to the negative 6 dilution. We know that 10 to the negative 6 is 1/1,000,000th. It's equal to 80. And another way to write 80 is 80 over 1. Now we have a simple problem to solve. 80 times 1,000,000 is 80 million. And then that needs to be changed to scientific notation. Since we have a 0 here, we're just going to add that decimal. We have 1, 2, 3, 4, 5, 6, 7. It's going to be 8 times 10 to the 7th CFUs per milliliter. That's one way to do this. Another way to do it is setting it up as 80 over its dilution factor here. And instead of dividing out 80 divided by 1/1,000,000th, you're going to write that as 80 times 10 to the 6th. And we know we have 6 zeros to add, so 80, and then 1, 2, 3, 4, 5, 6. We have 80 million, same answer. And then we need to change that, so we have 8 times 10 to the 7th CFU per milliliter. The common theme, instead of getting like a nice round number with a 0 here, is if it was like 87 instead of 80. And in that case, let's say like it was 87 million instead was your final answer. Your decimal goes here, And then it would be 8.7 times 10 to the 1, 2, 3, 4, 5, 6, 7. So this is my example from the Kahoot. During a serial dilution experiment, the sixth dilution, 10 to the negative sixth, had 190 CFUs per milliliter. What was the estimated original CFUs per milliliter? Now, we know that this one down here is our sixth. It had 190 colonies grow from the 1 milliliter that was taken out of it. So we just go right back to our problem here. 190 over 10 to the negative sixth. That's the same as saying 190 times 10 to the sixth. We know we just got to add 6 zeros to it. So 190, 1, 2, 3, 4, 5, 6. Now we convert that to scientific notation. We add that decimal right here, and then we have 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.9 times 10 to the 8th CFU per milliliter.